Many people find it confusing to use their heats of formation the first few times that they try it, so make sure that you try some sample problems for this. But here I'm going to give some guidelines for setting up one of these sort of problems. Now, the first thing you want to do is write a reaction that breaks each of your reactants and each of your products down into its elemental forms. Now that you've got that set up, we need to look at the heat of formation for each substance in those reactions. Once you've collected all those from tables or any other resource that you can find them in, we're going to multiply and divide the stoichiometry and the enthalpies. And if we need to, we're going to do some cross-canceling until we get our net reaction to match our target reaction. Next, we're going to add all those enthalpies together for each of the two sides. The other thing you can do is you can do that directly in one step by reversing the signs on any of your backward reactions. Personally, I like to add up all of the reactants, then add up all the products, and then subtract those two sums. But either way is appropriate. You can either change the sign and just put them all together right away, or you can do the two parts of the reaction halves, and then put them together at the end. Now, you'll find enthalpies of formation, standard enthalpies of formation, the degree sign means standard. You'll find those in Appendix 4 of the Tro textbook. You'll also find lots of sources online that you can find more from. Now, I also want to make sure that you understand, a real reaction is never going to have every atom break apart. But we know that these things are path independent. So we can just say, well, great, I know that I'm not going to have my hydrogen. Actually, let's do this one. I know that I'm not going to have my sulfuric acid completely break apart into hydrogen atoms, sulfur, oxygen atoms, and they're going to form from hydrogen gas, oxygen gas, and sulfur. I know that's not going to happen. But because I know that the standard states of each of those things are 0 for their enthalpy, I can then look up in a table how far is H2SO4 away from that form. And that tells me how much energy I'd have to use to break it all apart. Then I can go to the other side of the reaction and put all those atoms back together and figure out the energies. The reaction isn't going to do that, though. It's just going to break one bond at a time. But we can do that in calculation land in order to simplify our lives.